So I hope everyone enjoyed those demos, and I'll share screen now. I'm Dorita Viv. I am an assistant professor at the University of Pennsylvania's Weizmann School of Design, and I'm going to present today a project called BlockPen that we started about a year ago. And what we're trying to do here is to find a way to value improvement in personal environmental impact. And we all want to be sustainable. But when it comes to sustainability and environmental impact, certain things are harder to quantify and assign value to if you don't have the appropriate infrastructure to measure them. Students, staff, and faculty members have come to us and asked exactly this question: how do we assess our environmental performance? Many people share the desire to be responsible and improve their impact, but don't actually have the tools to even evaluate how they're doing in terms of sustainability and energy performance. This is especially true on campus where buildings are where the energy measurements are done for the whole building and not for individual users. So in this project, we're looking at the Penn campus and ask how to evaluate how much energy each person is using, what is their carbon footprint, and how it can be improved. Moreover, can you create a system that will reward people on an individual level to reduce their environmental footprint? To do this, we created BlockPen, a scalable blockchain network which connects a suite of IoT sensors to measure environmental parameters at the scale of a room across the Penn campus to provide an estimate of the personal energy performance to users over time. By using blockchain, we're able to use smart contracts to reward users with a point system that we call the Penn coin to incentivize reducing personal energy consumption. Essentially, we tokenize something that is usually hard to quantify. We're thus able to put value on energy savings. If you reduce your environmental footprint, you receive rewards. So let's dive a bit deeper into the system's workflow. A Raspberry Pi, which is essentially a small low-cost computer, which acts as a local node. Each Raspberry Pi is placed in a room and contains a blockchain node. A suite of sensors are also connected to each Raspberry Pi. The local nodes feed the sensor data to the blockchain, and the data on the Raspberry Pis is available for smart contracts on the blockchain to query and allocate Penn coins accordingly. These are some of the IoT sensors that we are using, and they allow us to assess several metrics. And those metrics can become the logic for the smart contracts. So we can pre-process data for multiple smart contracts based on these metrics. And other users can come up with their own metrics and write their own smart contracts. So really, this is an infrastructure for potential experimentation. In this use case that is what we're doing on the BlockPen project, smart contracts assign Penn coins or BlockPen points to users based on their rankings against their own history of performance and also against their peers. So what does that mean? Here is an example of how a smart contract can be applied to data we collect over time. And so in this case, the metrics is the energy occupancy factor. This is a factor that normalizes energy consumption per square meter by the occupancy. So what you see here is we're measuring CO2, which is a measurement actually for occupancy, because when there's people in a room, the CO2 spikes. And then we're measuring the power consumption. And here you can see how a certain user, this user's data is shown here, is doing compared to three other peers and the average in terms of how much energy this user is consuming per the time that they are actually in the room. So it's really different if you're not in the room and you are still consuming energy versus if you're there and you need certain appliances, etc. So you would be ranked differently based on that. And so here you can see how the smart contract would assign points to that specific users based on this performance. So our future goals as we go forward with this project is first to expand the system, which means more users, better accessibility, more functionality. And second, we want to develop more metrics. We think that this, this can be really, like I said, a field for experimentation. So we're looking to explore correspondence of sensor data to other metrics like climate parameters, grid carbon intensity, and more. Finally, these are the BlockPen team members, and beyond these people working with me in the University of Pennsylvania, we also have been working with external developers who've been helping us to develop the blockchain network. Thank you for listening, and I like to now give the stage to Professor Yuichi Ikeda to present his project.
Okay, thank you very much, Dorit, for a nice presentation. It was very interesting project, I think. So then, from our side, I'd like to show some of our recent activities. Just a moment. Okay, so I'd like to explain briefly our project on developing blockchain-based electricity trading system at Kyoto University. Okay, so actually we have problems in the collection of electricity charge at our students' dormitory in Kyoto University. So we decided to develop a simple system to manage the trading of electricity usage for students resident in our dormitory. Okay, so the goal of our project are the following three. The first one is to reduce the burden of students in charge of accounting and accounting staff collecting electricity bills in our dormitory. Okay, the second is to foster students' awareness for energy saving. The third one is learning blockchain technology by developing this prototype. Okay, so here is a photo of our residential college. In this photo, we see two buildings. Actually, in addition to this, we have three residential areas. So the total number of the students is approximately 80. So this is the environment to apply our system. Okay, so the next one is a system overview. Actually, we have two power sources. One is a power source from utility company. The other one is we have a small-scale rooftop solar PV panels. The capacity is approximately 100 kilowatt, so very small, but still we have this one. Okay, so, and also we have energy server. So this energy server record the electricity usage for the individual students. And by using some data acquisition software running on the system, we collect each student's daily electricity usage data. So this is not we haven't developed. We don't have our own device or a measuring apparatus to the for measuring the electricity usage. Okay, so and using this system, we send a warning to students who exceed the expected estimated usage, and we also send the actual ranking for the students. Okay, so then I'd like to show a stream of the actual operation. So still the system is in development, but I'd like to show the outline. Okay, so first one is a transaction at the beginning of the month. First, we estimate the usage of this month for each student and sell XRP tokens and at some price. And in addition to this, we sell a token to use the renewable energy. So the price of this token is little higher than utility electricity. Okay, so then during the month, students can buy or sell tokens according to their demand. Okay, but in the case of the shortage of token in the entire dormitory, the system will issue the additional token with higher price. Okay, so then in the transaction trading of token, we use this kind of very simple market. The market is operated using a single price auction method, and intersection of supply curve and demand curve will determine the price and quantity. Okay, so some students can buy the electricity, but for this case, they couldn't buy the electricity because the left side of the right side of the intersection, the trading will be rejected. Okay, so sometimes this kind of things can happen. So anyway, at the end of the month, system buy surplus token at the discount price from the student, and system sells additional token to students who do not have enough token at higher price. So as a result, the monthly income and expense, total income and expense will be zero. Okay, so we don't earn money from the system. Okay, so this is a brief stream of the system. Okay, so here's the schedule of our project. Currently, we are developing a system, and from early next year, we start the test and debugging and pilot operation. After that, we will move to the full-scale operation. So this is our project. Okay, then finally, I introduce team members. So these two people are my student, and she's our collaborator from Ripple Lab Inc. And in addition to this, we have three young entrepreneurs from CoCE Company Ltd. in Japan. Okay, thank you very much.
So I think we have a few minutes to discuss, and if I can just start with a question about your project, because I find it really interesting that you have you're aware of your different energy sources. You're either connected to the grid or to the solar field that you have, and I wonder. I mean, that's it seems like a great opportunity to also, because solar, you can always only store so much solar. So maybe at some time you need students to consume more energy to offload from solar, and then at other times you really don't want them to use it because it's night and you don't have solar and you have to rely on the grid. So could your system also incentivize using energy consumption during times that have the lowest carbon footprint, for instance?
Yeah. Thank you very much for the question. The capacity of the solar panel is very small, so we cannot supply enough energy, electrical energy to all students. But in meanwhile, we provide some carbon footprint to all students. Some students buy a token to use solar PV electricity. So those students have smaller carbon footprint. So we recommend to students to use solar PV, but the price is little higher than the utility electricity. So this is a current our plan for fostering the student awareness to the environment. Okay. Yeah, thank you. From my side, I have a question for you. I think you have a great advantage over our system because you have your own device to measure CO2 and energies and so on. So, I'm very curious about the system, and so actually, do you need a Raspberry Pi a small computer for each room, or
yeah. Mm-hmm.
I see. So I think how much does it cost for the student for each room?
Well, right now, we're providing all the equipment. Actually, we started our kind of prototype and first deployment are in offices. We realized, that's actually of a lot of interest is to actually study consumption in university offices. And the great thing about the Raspberry Pis and all the sensors we're using is that they're all low cost. The energy sensor is actually a little bit more expensive. There are plug load sensors that are low cost that we're also using, but we're also using direct current transformers on the panel box, which we need support of electricians from the university, etc. So there's more infrastructure to that. But for the actual Raspberry Pi and sensor kit, it's all very low cost overall. That's why we're using that. And the reason we need Raspberry Pi for each room is that all the sensors are connected to it via Bluetooth. So the sensors can be in a pretty big space, so different sizes of rooms if needed, but still within Bluetooth connectivity to the Raspberry Pi.
I see. Okay. Yeah, very nice. So the system is our weakness because we use a commercial energy server, so which is fairly high cost and no enough flexibility. But you have owned your developed system. So I think it is a very interesting approach to develop this system.
Thank you, and I think also I'm really interested in your project and how you're gonna, the study of how the fact that they have this system of transactions and they can now participate more actively. The students can participate more actively in how they're responsible for their energy bill. I'm wondering how that's going to change consumption patterns. So I think there's, it's very interesting to research, and yeah, I'd love to, let's continue talking and see how we can collaborate in the future.
Yeah, thank you very much. It is very nice for us. I appreciate your offer. So I want to we want to continue to discuss for the collaboration between University of Pennsylvania and Todd University. So this will be a good outcome from the UBRI activity. Okay.
Well, I think we need to move to the next chat. So thank you for listening to us, and great to meet you, Yuichi, and we'll keep in touch.
Yeah, thank you very much for Professor Dorit Aviv. We have a very productive discussion today. Thank you very much. So keep in touch, please.